The Mars rocket developed by Elon Musk is truly taking shape. After giving us a look at the prototype's fins on Monday, the SpaceX CEO opened the curtain on the Starship Mk.1 equipped with 3 Raptor engines, which is being built at SpaceX Boca Chica plant in Texas, and the upgrades were visible. SpaceX upgrades to the Raptor engines will blow your mind more than you think. Well, SpaceX wants to send the first rudimentary mission to Mars by 2029, and it is making incredible progress on its engine and making changes that scientists can't figure out how they do it. But what improvements have they made this time? And will this get us closer to Mars? Welcome to Smarter Tech for all the trending technology news around the world. We keep you updated always, and without further ado, let's get started. Firstly, you need to understand that the Raptor engines are massive liquid-liquid rocket engines that power SpaceX's upcoming launch vehicles. This engine is the third with a full-flow stage combustion cycle. It runs on super cold liquid oxygen and liquid methane. And when it comes to the FFSDC cycle of the engine, it is beneficial because it makes the most of the thrust that a certain amount of propellant can give. The Mars-bound spaceship will have 33 Raptor engines, 29 gimballing engines, and 10 gimballing center engines. Moreover, SpaceX has been making changes to the Raptor engine versions used on its vehicles for years. The Starhopper SN5 to SN11 use the V1 or Raptor 1 engine, and the SN15, SN20, and B4 use the V1.5 version. But when it comes to the latest engine, the Raptor 2, it's very different from the ones that came before it. It is more reliable and performs better. When comparing them side by side, it is easy to see the difference. While the Raptor 1 has a more chaotic appearance, the Raptor 2 has a more polished appearance. Many would concur that it nearly seems lacking. SpaceX needed a lot of development sensors to monitor pressure and temperature in the plumbing during the construction of Raptor 1 because the company was still learning. This is absent from the Raptor 2's V2 engine, which was completely redesigned to speed up production and reduce costs. As a result, practically every component was reduced in size or eliminated if it had no useful function. Consequently, Raptor 2's plumbing system was simplified to include necessary parts. Moreover, the valves have been merged and the valve plate simplified. Unlike the V1, which uses phalanges to bolt the compartments together, the Raptor 2's parts are fused. Before we continue, hold up. If you're watching us for the first time, make sure to hit that subscribe button and turn on notifications so you can enjoy our future videos while getting updated. Getting back to the topic, another step made by SpaceX to decrease the mass of the engine, eliminate leak sites, and increase its performance is to replace the flanges with welds. But it's more difficult for SpaceX to examine and repair specific pipes or section in a modular fashion without flanges because they're required in prototype development to swap out parts as needed. Fortunately, the Raptor 2's architecture is more reliable than the V1's, and the SpaceX can afford to remove as many flames from the engine as possible. Removing the torch igniters from the primary combustion chamber is another significant modification to the engine. The heated oxygen and methane gas act hypergolic under high temperatures and pressure from the primary combustion chamber rather than relying on torch igniters. The V2 engines are more heat and flame resistant due to the cleaner piping and broader combustion chamber throat, which also reduced the mass of the booster by up to 6 tons. The engine's compact design enables it to generate 320 tons of thrust. Elon Musk and the engineers in charge are convinced that it will reach 250 tons of thrust when the V2.5 debut on Booster 12, which would be a 35% improvement from Raptor 1's 187 tons of thrust. Moreover, the Raptor 2's thrust-away ratio at liftoff is 1.5, a 100% improvement over the V1's liftoff value of 1.12. Among its many advantages is that it uses less fuel during the booster's backburn. According to Musk, the finest part of the renovation is that there is no part mantra. Interestingly, in contrast to the V1, which needed weeks between launches, Raptor 2 may be launched again an hour after use thanks to easier production and lower manufacturing costs. With this, SpaceX can do more tests in less time and make the necessary changes without having to wait a long time. Still, there are some things that are the same in both versions. The engine manifolds are made of SX300 canal, which is a superalloy made of stainless steel. SpaceX makes this austenitic nickel-chromium-based superalloy in-house because it is resistant to heat and oxidation. By the way, this isn't the first time Inconel has been used in rockets though. Inconel X was used to make the skin of the X-15 rocket-powered plane. The plane took its first flight in 1959, which means that Inconel has been used in the business world for over 63 years. SpaceX has also used Conel in the engine manifold of the Super Draco rocket engine for Dragon V2 and the Merlin engine for Falcon 9. Now, the SX300 Inconel will be replaced by XS500, a material made by SpaceX that can handle up to 800 atmospheres of pressure. And by making its own version of the SX500, SpaceX is laying the ground for a more reliable and stronger turbopump for the Raptor propulsion system, which will make it as efficient as possible. Using 3D printing, the material is slowly being added to some Raptor engine parts. The material has been used successfully in the past. Elon Musk says that the Raptor engine can be used up to 1,000 times to get the most out of its methane fuels. At the end, both the version 1 and version 2 engines can be used more than once. SpaceX's ultimate goal is to keep making the Raptor easier and cheaper to build until it costs less than $250,000 to make one. But will this be possible? On the other hand, due to the high cost and low maintenance rate of 3D printing, the company also plans to use it less and eventually stop. Now you might be wondering, what are some of the Raptor's capabilities? Even though the Raptor engine is still young, there is nothing else like it. It opened the way for space travel that is good for the environment, cheap, and efficient, making the goal of a living on Mars seem like it could be done. I mean, who doesn't want to go to Mars, right? Because it can be used more than once and it is easy to make, several Raptor-powered spacecraft can be launched several times a week, carrying more cargo than any NASA vehicle has ever been able to. Starship can send twice as much to the moon as the Saturn V, which is one of NASA's most powerful vehicles. And since it can carry more weight for less money, according to estimates, cargo launches could cost as little as $10 per kilogram. For exploring Mars, they could send out lots of equipment like rovers to speed up building a self-sustaining habitat there. The cost of Musk's 10-year plan to settle Mars will be $2.08 billion per year, which is a lot less than NASA's SLS. The payload on the SLS is smaller and each launch costs more than $2 billion. The SLS isn't easy to beat because some made it of NASA's best engineers. Evidently, Starship is better in terms of design and cost though. For business travel, the Starship can take people from one place to another in just a few minutes. For flights that don't go into orbit, the Starship will be able to carry 230 tons of cargo, which is twice as much as the biggest long-haul planes in the world can carry. If possible, SpaceX wants to make a lot of Raptor engines for less than $300,000, and a finished Starship is expected to cost as little as $2 to $3 million. With a production cost of $30 million, the Starship is already 5 times cheaper than a commercial plane, and when the final version is done, it could be 60 to 100 times cheaper. It will be 20 times faster than a commercial flight, so a trip from New York to Paris will only take 30 minutes instead of 7 hours and 20 minutes on a regular plane. With a ballistic vehicle, a trip from London to Hong Kong that would usually take 11 hours and 15 minutes would only take 34 minutes. The Starship's cabin is 825 cubic meters big, which is bigger than an Airbus A380 jet plane. For the Mars trap, the Starship can have up to 40 rooms that can hold up to 6 people each. This means the 120 people can go to Mars at once, but when the Starship is used for commercial travel, it will be able to carry 1,000 people at once. Nevertheless, we wish them all the best. But well, what are your thoughts on the SpaceX Raptor engine? Comment down below. Also, please leave a like and subscribe. Don't forget to turn on the notification bell for more amazing videos. Goodbye!